In this video, I will teach you how to answer Chemistry Paper 3 Operational Definition. This is a 3 marks question. And in this video, you're going to learn how to get 3 marks or at least 2 marks for operational definition. So what do you have to do in order to get these 3 marks? So all you have to do is give me a simple sentence that consists of what is done and also what is observed in the experiment. So what is the meaning of what is done? The meaning of what is done is you have to give me a procedure of the experiment, which means the step, which is telling me how you do the experiment, how you carry out the experiment, the procedure. Well, what is observed is you have to give me the observation of the experiment. After you have done something, and then what can you observe from what you have done? So let us look at the experiment in this page. So the first experiment here is about the reactivity of alkaline metal with oxygen gas, as you can see from the diagram here. Alkaline metal, lithium, sodium, potassium, they are reacting with oxygen gas. And let's see, what is the question about? Give the operational definition for the reactivity of alkaline metal. So they want us to give operational definition about the reactivity of alkaline metal. And then the second experiment. This is an experiment about the reactivity of halogen with hot iron. As you can see from the picture again, we have halogen, bromine, chlorine, and iodine reacting with iron wool. And these questions want us to give the operational definition for the reactivity of halogen. You can see these are two very similar questions, and then I also use these two experiments to show you the two ways of writing the answer. So how do we do this experiment? So what we do in this experiment is we react the alkaline metal with oxygen. Okay, this is what we do. We put the alkaline metal into the gas jar containing oxygen gas. We put it in, and then they react. And then what is observed? So what is observed? Instead of what is observed, you should think what to observe. In order to find out the reactivity of alkaline metal, in order to know the result, you want to know the result by observing it. How you know which one is more reactive? You see, when you look at this observation, burn slowly, burn vigorously, very vigorously, you can see the alkaline metal is burning with different brightness of flame. Correct? So how you can relate these two sentences together? Let me give you one example. You have a friend who is always complaining they are very fat, but then they still eat a lot. So you'll be saying, you see, the more you eat, the fatter you get. So this is what you have to do here. Alkaline metal, we have different alkaline metal here. Lithium, sodium, potassium. We cannot just say lithium put into oxygen, red flame, because it doesn't talk about sodium and potassium. You have to give a statement that feels like include everyone. Lithium, sodium, and potassium. So this is what you can do. A tip here. To make this sentence, you can always make comparison, which is telling me the relationship. So alkaline metal has different reactivity. So if the alkaline metal is more reactive, what happened? The flame will be brighter. So you see, this is how I answered this question. I said that a more reactive alkaline metal. Example here is potassium. Burn in a gas jar containing oxygen gas. You see, this is what we do in the experiment. We allow alkaline metal to burn in a gas jar containing oxygen gas. And then, by saying more reactive alkaline metal burns with oxygen gas, a brighter flame is produced. You're kind of like telling people, oh, if you do this experiment, the more reactive one is going to get a brighter flame. This statement is kind of like it includes everything. Instead of saying sodium burn in oxygen gas, we get yellow flame. Lithium, we get the red flame. So you see, this is like, you can't tell the whole result in one sentence. In order to tell the whole result in one sentence, you can compare like, oh, if you use more reactive alkaline metal, the flame will be brighter. And then people will know, oh, if I use more reactive, the brighter flame I will get. Then, this experiment, I use a different way to answer it. So you can see, this experiment, reactivity of halogen, we have different halogen. So what we do here is halogen now react with iron. This is what we do. And then, what is observed? What is observed? Glows brightly, burns brightly, glows dimly, eh? So this is like the same, brightness of flame. So I can make a comparison so that I can include everyone in my statement by saying that if the halogen is more reactive, what happened? The flame will be brighter. So you see, this is a different way of writing the same thing. When halogen, chlorine, bromine, and iodine are passed over hot iron wool. You see, I mentioned what I did. Halogen. react with hot iron wool. And then, to be more detailed, I mentioned chlorine, bromine, iodine, which is exactly what is used in the experiment. So I say, if you burn chlorine, bromine, and iodine in hot iron wool, the more reactive halogen burns with a brighter flame. Can you see? I also make a comparison so that people know, oh, if you use a more reactive halogen, you will get a brighter flame. At this point, I think you are slowly getting the way of how to write this operational definition by including everything you do and everything you observe in one simple statement. So remember, to make this sentence to be more smooth, you can always use comparison. Okay, so this is the first tip that I gave you. Now, let us look at the next experiment. This experiment is carried out to construct the ECS based on the potential difference between two different metals. So how can you get potential difference, which is voltage, by using two different metals? So how you do this? So what we do in this experiment is, can you see? We are putting different pairs of metal into the copper 2 nitrate solution. So different metal or metal pairs into the copper 2 nitrate solution. This is what we do. And then, what are we going to observe here? By putting different metal into the solution, we are definitely going to get a different voltage. So what we are trying to observe here will be the voltmeter reading. Okay, let's see. They want us to give an operational definition for the construct of ECS in this experiment, that means based on this experiment. So what we do here, different metal into the solution, we get different voltmeter reading. So let's make a comparison. Different metal, different voltmeter reading. From what we have learned before, if the two metals in the ECS are further away, then what happens? The voltage will be higher, let's say 3, and then this is 2. The further the distance, the higher the voltage, correct? So you see, my answer is two metal electrodes further in ECS connected to voltmeter by connecting wires are dipped into copper 2 nitrate solution. So this is what I do. I put different metal into copper 2 nitrate solution. And then I say further, I compare it. Further, it's going to get a higher voltmeter reading. So this is my statement. Very simple. Next experiment. This experiment is about displacement reaction. So we are using displacement reaction to identify the position of metal in the ECS. So the operational definition, what do we do here? We are putting different metal into different salt solution. Metal into salt solution. And then, what do we observe? You see, solid deposited. Okay, I will see solid deposited. So we can make a comparison here, which is when we are using a more electropositive metal, what happened? Solid will be deposited. So we can use one of the example here, which is when I use a more electropositive metal and put it into the salt solution. Which salt solution? We have a lot of salt solution here. 1, 2, 3. You can simply mention one here. For example, I want to use copper 2 nitrate solution. So this is what I can say. When a more electropositive metal, like magnesium, is added into copper 2 nitrate solution, a brown solid is deposited. A more electropositive metal, like magnesium, is added into copper 2 nitrate solution, brown solid deposited. So you see, from my statement, I tell people that as long as I'm adding a more electropositive metal into a salt solution, metal will be deposited. So I can also make another answer, similar answer, like this. When a more electropositive metal like copper is added into silver nitrate solution, what happened? Shiny grey solid deposited. Can you see? As long as a more electropositive metal is being added into the salt solution, solid deposited. Next experiment. This experiment is carried out to investigate the role of the type of solvent in showing the properties of acid. And the question wants us to give operational definition of acid. So you see, what are they doing in the experiment? Hydrogen chloride in water react with calcium carbonate powder. Hydrogen chloride in methylbenzene react with calcium carbonate powder. And then what we observe here is bubble, no bubble. So what we do is HCl with different type of solvent added into calcium carbonate. And the observation is bubbles. For experiment like this, you can't do comparison. You can't say hydrogen chloride which is more water, or hydrogen chloride that is less water. You can't do that. You can't make a comparison. You see, this question they say acid. They want the experiment to show acidic property. So which one is showing acidic property? Number one, right? So for this kind of experiment, you are not going to make comparison. You're going to say hydrogen gas flow into a test tube containing water and calcium carbonate powder. You see, HCl in water reacts with calcium carbonate. This is what we do. Hydrogen gas, water, calcium carbonate. What happens? What we observe? Bubble. So colorless gas bubble is released. So what we do here is, when we react hydrogen chloride gas containing water with calcium carbonate powder, colorless gas bubble is formed. Of course, you can change your sentence to, when calcium carbonate powder is added into a test tube containing hydrogen chloride in water, colorless gas bubbles are released. Just like that. Okay, you can always change your sentence as long as it includes what you do and then what you observe. Then you will get 3 marks. Next experiment. This experiment, they are comparing the strength of 2 different acids based on their pH value. And this question wants us to give the operational definition of the strong acid. So you see, this is what we do. We have 2 different acids that come with same concentration. So the strong acid is obviously the hydrochloric acid. Now we are going to tell them what we do. So when a strong acid, hydrochloric acid, and a weak acid, actinoic acid, with the same concentration are ionized in water. Okay, so this is what I do. It is like I put them 2 into the beaker. And then the strong acid will show a lower pH value. So this is kind of the same as relationship. Stronger acid, lower pH value. So that's why I say lower pH meter reading. So this is what you can do. Next question. So this is an experiment that wants us to study the solubility of salt in water. And the question wants us to give the operational definition for soluble salt only. So let's see the result. Copper 2 sulfate solid becomes blue solution. It has dissolved. That means experiment 1, soluble. Zinc carbonate solid, the solid still remains. That means it is insoluble. Lead-2 nitrate solid, colorless solution. Oh, it is soluble. So how can we make this operational definition? First, tell them what we do. For the soluble salt, copper 2 sulfate solid and lead-2 nitrate solid, we add them into water. Okay, we add them into water. Copper 2 sulfate, lead-2 nitrate solid added into a test tube containing distilled water. What happened? If they are a soluble salt, what happened? The salt will dissolve into the solution. So this is what you observe. When you put these 2 salt solid into water, they dissolve. Just like that. Next experiment. This is our Form 5 Chapter 1, rate of reaction. This experiment is carried out to study the effect of size of solid reactant on the rate of reaction. So you can see they are using hydrochloric acid to react with zinc powder and pellets which are different size. This question wants me to find the operational definition of the rate of reaction for this experiment. So what do we do in this experiment? We react HCl with zinc of different size. And then what do we have to observe in order to know the rate of reaction? In order to know which reaction is faster, what do I have to observe? I have to see how fast the gas will fill up the burette. So I have to observe the volume of gas. What gas is this? Hydrogen gas released over time. Rate of reaction, right? Quantity over time. I want to know how fast the gas will fill up the burette. Or I want to know in the first first 30 seconds, how much gas can be collected. So you see, I can make a comparison here by saying size of zinc smaller, my rate of reaction will be higher. So when my rate of reaction is higher means the volume of gas collected will be higher for the same time taken. So you can see, when a smaller size of zinc, which is my zinc powder, is added to hydrochloric acid, you see, this is what I do. HCl react with zinc, smaller size. Volume of gas collected in the first 30 seconds is higher. So you see, this is what I do and then what I observe. And then I use comparison, smaller size, higher rate of reaction. How do I know whether the rate of reaction is higher? Volume of gas collected in the first 30 seconds is higher. So I make a comparison. Next experiment, we have this. So what is this experiment about? This experiment is to study the effect of temperature of sodium thiosulfate solution on the rate of reaction. So same, the question wants me to give the operational for the rate of reaction. What do we do in this experiment? You can see, we are reacting sodium thiosulfate solution between sodium thiosulfate solution and sulfuric acid. So sodium thiosulfate solution with sulfuric acid. And we are using different temperature of this sodium thiosulfate solution. What do we have to observe in this experiment? How I know the rate of reaction will be higher or lower? I have to observe what? I have to observe whether my X mark has disappeared or not. And then, over time, same thing. How long does it take for the X mark to disappear? Answer. Higher temperature. I make a comparison. Temperature higher. What happened? Higher temperature of sodium thiosulfate solution is added into a fixed volume and concentration of sulfuric acid. This is what I do. And then the time taken for the X mark to disappear is shorter. When temperature higher, rate of reaction will be higher. Rate of reaction higher means the time taken will be shorter. The X mark will disappear faster. So you see, I make a comparison. Higher temperature, lesser time taken for the X mark to disappear. So just like that. The next experiment. This experiment is the same as the previous one, which is a reaction between sodium thiosulfate and sulfuric acid. But the factor this time is different. The factor this time is concentration of sodium thiosulfate solution. Question want me to give operational definition for the rate of reaction. Same thing. What we do here is react the two solutions together with different concentration. And then what we observe here is the same. Time taken for the X mark to disappear over time. So answer same. Just change the word temperature to concentration. So concentration higher. Time taken for X mark to disappear shorter. Relationship, what I do and what I observe. Okay, and then next we have this one. This is a Form 5 Chapter 2 experiment to study the sootiness of flame produced by hexene and hexane in combustion. This question wants me to give the operational definition for the sootiness of hexene and hexane. So that means they want me to compare which one produces more soot. What I do in the experiment is, you see, we are burning hexene and hexane. So that means this is a combustion of hexene and hexane with oxygen, burning them. Observation. What do we have to observe? In order to know which substance produces more soot, we have to see the amount of black spot collected. Amount of black spots collected on the filter paper to judge whether which one has more soot. Same thing, we can make a comparison here by saying, okay, hexene and hexane, they are both hydrocarbon. But one of the hydrocarbon has higher percentage of carbon by mass. Which one? It is, you can see the result here, hexene has more black spots. So that means hexene. So you see, my first point here I say, what I do is, when a hydrocarbon with higher percentage of carbon by mass, which is hexene, is burned, my observation, I compare the amount of black spots. Higher percentage of carbon, of course, you're going to get more black spots. So more black spots are collected on the filter paper. Comparison. Next, we have this chapter 3 experiment, which is about rusting. We want to study the effect of metal on the rusting. That means how other metal affect the speed or the rate of rusting. This question wants me to give the operational definition for the rusting of iron. So you see, what do we do here in this experiment? You can see, we have iron nail that is in contact with different metal P, Q, and R. And then, these two substances are placed in jelly solution, potassium hexacyanophthalate 3 and phenolphthalein. They are all the same. So you can see what we do here is, we have iron with different metal added into jelly and blah blah blah. Rusting of iron. How I know whether the iron has rusted or not? What do I have to observe to know whether the iron has rusted? So here we have two observations. Which observation will tell you the iron better whether it has rusted or not? The answer is the intensity of blue color. If the iron has rusted, they will show blue color, non, and very high. So you can see the rusted iron is the one with metal R. Comparison. What we can compare here is when iron is in contact with a metal that is less electropositive. That means lower than iron. Okay, less electropositive. Less electropositive. What happens? You are going to see blue color. So you see my answer. When a less electropositive metal is coiled together with iron nail and placed into a test tube containing jelly solution, phenolphthalein, and potassium hexacyanophthalate 3 solution. This is what I do. And then what I observe is blue spots are formed. Or you can also say the intensity of blue color is very high. Like that, okay? Blue spots indicate the presence of rusted iron. So this is the experiment of rusting. Next, chapter 4, thermochemistry. This experiment is using different metal from the ECS to study the heat of displacement. So you can see in the experiment 1, they use zinc powder to react with copper 2 sulfate solution, and then magnesium powder, copper 2 sulfate solution, iron powder, copper 2 sulfate solution. You can see they are using metal with different electropositivity from the ECS to react with the same copper 2 sulfate solution. So here, this is what we do. We mix different metal with the solution. Observation. Let's read the question first. The question wants us to give the operational definition for the heat of displacement. How to know whether the heat of displacement is higher or lower? What we have to observe is the thermometer reading. So let's make a comparison between what we do and then what we observe. If we are using a more electropositive metal like magnesium, a more electropositive metal reacts with copper 2 sulfate solution, more electropositive, and then what will happen to the thermometer reading? If we use more electropositive metal, then the thermometer reading will be higher. So you see, this is my answer. More electropositive metal like magnesium added into copper 2 sulfate solution, the increase in reading of thermometer is higher. Okay, so we make a comparison. Most of the operational definition, you can make comparison. Next experiment. This experiment is about heat of neutralization by using two types of acid. You can see experiment 1, nitric acid, experiment 2, ethanoic acid. Same thing, they are reacting with same potassium hydroxide solution, different acid, potassium hydroxide solution. This is what we do. What do we have to observe? The temperature again. Okay, operational definition for heat of neutralization. If we use a stronger acid, the increase in the thermometer reading will be higher. So when a stronger acid, nitric acid, is added into potassium hydroxide solution, what I do? Increase in the thermometer reading will be higher. So same, I make a comparison. Next, this is almost the same. It's also heat of neutralization by reacting sodium hydroxide and hydrochloric acid. But the question is different. The question wants us to give the operational definition for exothermic reaction, which is different from the previous question. Previous question wants us to find heat of neutralization so we can compare the heat release high or low. But this time, they just want us to prove that the reaction is exothermic. So what do I have to observe? When I react sodium hydroxide with hydrochloric acid, how I know that the reaction is exothermic? What do I have to observe? So what I have to observe is the same. If it is exothermic reaction, thermometer reading will increase. So you see, what I do, when sodium hydroxide solution is added into hydrochloric acid, reading of thermometer increases. That's all. This proves that it is exothermic reaction. Acid and alkaline react together, we get increase in temperature. Next experiment. This is heat of combustion between methanol, ethanol, propanol, and butanol that has different number of carbon atom in their molecule. So we can make a comparison. This is what we do. Burning different alcohol with different carbon atom. And then the question want me to find heat of combustion. So you see, when an alcohol with more carbon atoms per molecule is burned, this is what I do. And then increase in the reading of thermometer will be higher. I make a comparison. If the alcohol has more carbon, then the heat of combustion will be higher. That's all. This is the last experiment from the last chapter. This experiment is to study the cleansing action of soap and detergent on a pair of socks with oily stain. So they want me to give operation definition for experiment 1. In the experiment 1, what are we doing? We put these socks with oily stains into a mixture of detergent and hard water. This is what we do. And then what is our observation? You see, after we put it in, the oily stains are removed. So we just have to make a simple sentence based on this experiment 1, which is pair of socks with oily stain is added into the mixture of detergent and hard water. The oily stain is removed. Just like that. Okay, so that's all for operational definition.